Hi, so let's look at this question here, which was taken from the year 2019 paper 1 question 11. I believe this question is on differential equation. Let's see if we can do this proficiently. Now, the first thing is, let's see try and draw a sketch or try and understand the question is talking about. So you're told that the scientists begin to investigate how hot water actually cools down, and the water is heated at a container and then placed at the room which is kept at a constant temperature of 16 degrees. Okay, so if this is a container, there's hot water inside. So there's a room temperature here, which is actually held constant at 16 degrees. Okay, so room temp is constant. Great, so we try and understand this. So then, after which the temperature of the water T after of water T minutes. So at T minutes, right, you know that it will be a function water temperature will just be theta Celsius. Okay, so that's one. Then the temperature decrease at a rate proportional to the difference between the temp. Okay, this is important. This sentence here is actually important. Okay, so let me just type out this sentence here, which and try and understand this. The temperature decreases at a rate proportional to the difference between the temperature of water and the temperature of the room. Let me just type this out. So this this sentence here would be the one which gives you the formula of the differential equation. The temperature decreases, so this temperature is decreasing, meaning to say this is d theta dt, right? Proportional meaning it's a fishy sign. The difference between the temperature of the water is theta, and the temperature of the room, which is held constant, which is at 16 degrees. Okay, so this is a pretty standard question, which you've seen it, and we've done it many times in lessons, during lessons. So this part here, what we do is actually just put d theta dt. This is the decreasing rate. So what we can do is actually just proportional. The temperature difference, obviously we want it absolute value. The water is obviously hotter, right? Because this is hot water. Okay, at theta degrees Celsius. So we will expect theta degrees Celsius to be more than the room temperature if it's a hot water. So we'll just put theta minus 16. This is what you could deduce, right? The rate of change of the temperature is actually proportional to the difference between the water and the temperature of the room. So what you can write here is d theta dt. Because it's a decreasing rate, you can put minus k theta 6, okay, where k is a positive constant. Okay, this is the first thing that we need. You must be able to write it out. Now once this is done, we're gonna proceed to see what else. The temperature of water fills from a value of 80 degrees. So from 80 degrees to 32 degrees. Okay, the time is in minutes, T minutes, right? T minutes. So at T equals to 0, you have theta equals to 180. Then after which at T equals 30 minutes, you will have theta equals to 32 degrees. Okay, so let's see how we can solve this properly. This is a boundary condition. So this boundary condition will help you to solve the unknown which you'll find. Okay, so this case here, this is a separable form. Remember this part here. I think this is not really a difficult question per se. You have to be able to do this here in exam. So this d theta dt equals to minus k, after which we just integrate. This will be d theta minus 16 dt equals to minus k integral 1 dt. Okay, integrate k is fine as well. So this case here will be ln theta minus 16 equals to minus k t plus c. Make theta the subject, that will be easier. So theta minus 16 equals to e minus k t plus c, plus minus. Okay, so plus minus because it's modulus here. So this case here, what we're going to get is actually this is plus minus ec dot with e minus kt. A would just be plus minus ec. There you go. So this will be a e minus kt plus 16 theta. Alright, so I just leave it there. Then after which I'm just going to bring my boundary condition here. This boundary condition helps me a lot because when t equals to 0, so t equals to, when t equals to 0, we know that the temperature was 80 degrees at the very start. Alright, so this is important because once you use this to sub into this expression here, which is 80 degrees equals to a E0 plus 16, you can actually solve your a straight away. So E0 is 1, a will be 80 minus 16. Okay, so this case here will be 64 degrees. Now when t is 30, we know that the when t is 30 minutes, theta was 32 degrees. So just put into calculator here, this will be 32 equals to a, which is actually 64, and e, which is minus k, which is k, 30 plus 16. Okay, so now that I have my a is 64, right? So I'm just gonna replace 30 and so on into this expression here. So that's pretty okay. Once this is done, what we need is actually just solve for our k. Okay, so our k here will just be 32 minus 16 over 64 e minus 30k. So this is 32 minus 16 over 64, which is actually 1/4. After which we're just going to ln both sides, and this will be actually just okay, right? I'm just going to leave it as minus 30k equals to ln 1/4 here, and basically k 1 over 30 ln 1/4. Okay, great. So this is how you solve, because now you want theta. So theta is equals to, in an exact function of t, so in exact meaning to say we need this expression theta. So we have a is 64 and e minus k, so is plus 130 ln 1/4 plus 16. Okay, just replace all of it into this expression here, then you will get answer. Okay, so this is how you do this question here proficiently. Sorry, I made a mistake there, kt, so there's a t here. Okay, so there's a t here. Yeah, could you further simplify? Let me see. Yeah, this is okay. You can just leave it as such, exact.